Hello everybody, my name is Takeuchi, and I will be talking about earthquakes and magnitudes using logarithmic functions like the Richter scale. A little fun fact about earthquakes is that they are caused when rocks underground suddenly break along a fault, which then releases energy. And the most common way of measuring earthquakes is the Richter scale, which was founded by Charles F. Richter. And the largest earthquake to hit the US had a magnitude of 9.2 back in 1964. So the first problem we're going to look here is the equation. So the first Richter scale is a common way of measuring the intensity of an earthquake. Earthquake A had a magnitude of 6.4, while earthquake B had a magnitude of 8. What is the value of x when earthquake A is 7,943.28 times more powerful than earthquake B? Round to the nearest tenth. And this is the Richter equation. So what they give us is earthquake A is 6.4 and earthquake B is x. So we would solve it as if we are trying to solve for how much powerful earthquake A is compared to earthquake B, but we just have we don't know the value of x. So we're going to try to isolate it. Also, we know that earthquake A is 7,943.28 times more powerful. So, based on the information we give us, we're going to solve it as if we were trying to find how much more powerful earthquake A is compared to B. So, what that is basically we try and find the difference between the two Richter values, the magnitude. So in R1 minus R2, that's the difference between the two magnitudes. And we are going to just plug in the equation. That'll be log A1 over T plus B, and we're going to subtract that by the log of A2 over T plus B. We just basically wrote out the two differences that were shown here. So what we do from there is then we plug in the value for R1. In our case, that would be 6.4. And we will subtract that by x, since that is the unknown value. And since we can combine like terms, b minus b is 0. So we can just ignore that, and we can head on to this. A1 over t minus the log of A2 over t. Now, we can use the quotient rule and try and make this one function. So what we do there, we will keep this the same. Minus x is equal to the log of A1 over t over the log of A2 over t. So we can right away find out that there is a t in the denominator, and we can cancel that out by multiplying t on both the numerator and the denominator, which would cancel out the t's, which would leave you with logarithm of A1 over A2. That would be 6.4 minus x. There we go. So we will try and exponentiate it by 10 on both sides so we can get rid of the common logarithm. So we will exponentiate it by 10, which will cancel these out, and we will have 10 to the 6.4 minus x power, which is equal to A1 over A2. Now this value right here is basically A is however many times greater than b. Now, we already know that A is 7,948.28 times, or 43.28 times more powerful than earthquake B. So basically what this is saying is that these can be equal to each other, which basically means, sorry about that, we'll cover a new place, which basically means we can set these equal to each other. When we do that, we can do 10, 6.4 minus x equals 7,943.28. So when we do that, now we want to try and isolate x. So what we do here is we can just take the log, the common log, on both sides. So we take the common log, cancel these out, make this isolated, and we can find the log of this, plug it into our calculator. So we would do the log, of 7943.28. When we do that, we should get 43.28. We should get the value 3.8999, which basically is about roughly 3.9. So when we do that, we can do 6.4 minus x equals 3.9. I say 3.9 because we are rounding it to the nearest tenth. So what we do here now is we subtract 6.4 on both sides, right? And when you do that, you should get negative 2.5 is equal to negative x. We can just divide each side by negative 1, and you get x is equal to 2.5. So the value of x, going back to the problem, the value of x when earthquake A is 7,943.28 times more powerful than earthquake B, it will be 2.5. For problem number 2, we have the data table example. So to our left, we can find the top 10 most powerful earthquakes in Alaska, but not only Alaska, but actually in our whole US. So the question is, what is the most powerful earthquake, and how much more powerful is it compared to the earthquake that hit Rat Islands? So looking at the actual data table itself, what we can see is that clearly Prince William Sound has the greatest magnitude. So therefore, the most powerful earthquake, let's just abbreviate it, most powerful earthquake would be 9.2 in the table. So it would be Prince William Sound. Prince William Sound. So the second part of the question is, how much more powerful is it compared to the earthquake that hit Rat Islands, round to the nearest 100ths? So what we do in this case is we want to take the difference of Richter, the magnitude, and take or exponentiate it by 10 in order to get how much more powerful it is. So what we do in this case is we take, let's just say R1 is equal to the largest value, so 9.2, and R2 is equal to the value of Rat Islands. Rat Islands is around here, which is 8.7. So we'll say that R subscript 2 is 8.7. What we would do from there is we would apply the same equation. So that would be 9.2 minus 8.7, which is equal to the log of a1 over t plus b minus the log of a2 over t plus b. That's a plus. Oops. So from there, what we're going to do is we are actually going to take the difference of these two numbers. So that would be 9.2 minus 8.7, which is equal to 0.5. 0.5, and we will combine like terms. So b minus b is 0, so we will not have these anymore. And we will let 0.5 equal to the log of a1 over t minus log of a2 over t. So from there, we can use the quotient rule in order to make it one equation. So that would be a1 over t over the logarithm of a2 over t. Right. 0.5. So from there, what we want to do is we want to multiply the reciprocal by t, or we want to multiply t on both the numerator and denominator. So we can cancel out the t in the denominator, and we can make this a more simplified equation, which is this, 0.5. So what we do now is we want to exponentiate it by 10, both sides by 10. So we can cancel out the common log because the common log has a subscript of 10. And so 10 would cancel it out. And what we want to do is write out the function now. So what we do now is we want to put into our calculator 10 to the power of 0.5. And when you do that, you should get value about 3.1623. And since the question asks for you to round to the nearest 100ths, you're going to round it to 3.16. So that means that Prince William Sound had an earthquake that was 3.16 times more powerful. Compared to Rat Islands. And that is basically number 2. For problem number 3, it is a graphing problem, and here's a question. There are approximately 13,000 earthquakes each year. How many orders of magnitude greater is 2010 compared to 2002? By 2010, I mean the earthquake from 2010, and it is compared to the earthquake from 2002. So in this problem's case, it is relatively simple, in which the earthquake from 2002, you can see that it has a value of 6.3. So we will write 6.3. Oops. 6.3. And the value, the Richter value, or the magnitude from the earthquake from 2010 is roughly 7.5. So when the question asks you how many orders of magnitude is greater, that basically means the difference between the two magnitudes that you're comparing. So it's basically 6.5 minus 6.3. And when you solve that, it should be 1.2. So the way you answer this question would be the earthquake from 2010 is 1.2 orders of magnitude greater than the earthquake from 2002. Here are my sources. Thank you and have a wonderful day.